In this quick review, we'll be looking at cardiac output and inhalational induction. Before we begin, let's orient to the diagram. You see here, we have our machine and vaporizer, our circuit and reservoir bag. We have our tube and the Y piece, and we will represent the lung with this blue circle. We'll represent the vessel-rich group that includes the brain, the heart, the liver, and the kidneys. We'll also include the muscle group and the fat group. Now, if we remember, each of these groups all have a certain percentage of the cardiac output, and they all take up a certain percentage of the body mass. But for this particular video, let's just look at circulation and how quickly or how slowly it's moving. Now, if we look here, we have these purple dots that are representing, in this case, a moderately soluble agent known as isoflurane. And it's in our lungs. We've overpressured our system, and we've got the molecules to the lung, and now they're interfaced with the circulation. Now, if you notice these little slits, if you will, in each of these, remember that each of these agents that we use has a solubility for one of the various tissues. And we know that these molecules are highly soluble in the fat. They have a high solubility in the muscle group, and they are also soluble in the vessel-rich group, but maybe not as much as they are to the fat group and the muscle group. We also see that the muscle group is a large component of the mass of the body, and so is the fat group. But we know that most of the cardiac output goes through the vessel-rich group, followed by the muscle group, and then the fat group. So we always say that cardiac output, when it speeds up or when it increases, will make you go to sleep slower. Well, let's think about that. We get this molecule and it's just racing around, right? It's racing around, it's racing around. What do you think, or how do you think it is interfacing with each of these components, right? We see that it's very soluble here, so it's going to be easy to escape into the fat. Right? It's moving around, it's moving around, it's moving quickly, but we don't have a lot of contact time with the vessel-rich group, right? It's just speeding right by. And so our other tissues, our muscle group and our fat group, will see a large proportion of these molecules before our vessel-rich group, which includes our brain here. And though we think intuitively that there's more flow so that you should go to sleep quicker, we don't. And that has to do with the amount of time that the molecule interfaces with the particular tissue in question. Now let's look at a slow cardiac output. We have this molecule and it's moving very slowly, and we know that it has a solubility for all tissues, and so since it's moving very slowly, why not stop at the brain first, right? Or one of the vessel-rich compartments. It's moving very slowly, it's moving very slowly. Right? So in this case, we'd go to sleep much quicker than if our molecule was racing around the circulation and then dropping off into one of the tissues in which it's very soluble. I hope this helps. Thanks.